Alrighty, we got a Nick and Time design update coming at you. So it's been a little while since the last update, so I figured I'll just catch everyone up to see where I'm actually at. So first off, Trinity fan controllers, the wonderful TFC. We now have version 2.1. So this is an updated version that fixes all the issues that I found in the V2 prototype batch. So this thing is absolutely gorgeous now. I don't have any issues that I can think of. All the circuits are actually working now. Everything's laid out properly. Everything is just, oh man, it is beautiful and gorgeous, and I'm really happy with it. It's nice to see a product that like you can actually feel like you're done with it, you know? Like, yeah, I'm not worried about anything else that I need to add. And the big reason behind that is because I used all the pins on the chip. There's no more extras. I've used them all. So yeah, there is that beautiful bastard right there. So yeah, there are no more free pins. Everything is pretty well used up. But yeah, this has just got a couple different little fixes. Nothing too crazy. So it's really just, you know, refining the board, adding the stuff in that I was missing, things like that. So now the second temperature probe reading works now. We've got proper footprints for like flyback diodes and other things like that, just changing the way vias are laid out. But the biggest change is really on the stock voltage reading circuit. So for people that are looking to read in a factory sensor that is still used by the like, you know, a computer or other thing, it's hard to read a sensor that's already in use. Because we're not reading the resistance anymore, we're reading the voltage of the other circuit. So that gets a little complicated. So that's what all this hoopla is about. First, I had to make this really high impedance so that it doesn't mess with the circuit, because, you know, this is a very, very high resistance short to ground, so that'll throw the reading off. So the higher the impedance you can get, the less it'll affect the circuit. But there is a bit of an issue that the Arduinos need a kind of low impedance circuit to actually properly read in. So we're kind of, you know, fighting each other here. How do you not mess up the circuit but still read in the reading properly? Well, that's where the capacitor comes into play. This little guy right here. So what this does is it charges up as the stuff flows in there, and then when it reads, it takes a little gulp, and that capacitor can, you know, fill the gap momentarily. So it's a really cheap solution, and the only issue is that it averages the circuit a little bit, but we're talking like a really fast average. It's not a big deal, especially for temperature. We don't need super fast, so that's not a problem. But we didn't just stop there. So okay, of course we can read it in now, but we still got to figure out some of the internal values. So I've made an automated circuit for that. Here we have a reference resistor that is controlled by a transistor, so that way we can turn that resistor on and off and use it to calculate what the voltage and the resistor in the computer is. So that's super useful. So basically, all that in a nutshell is I can use smart code, and this thing will do everything you need. Just unplug the sensor, plug this into the wire you're trying to probe, it'll figure out the stuff, and then you plug the sensor and it should work. So yeah, less thinking for you and more smart for me. So about the only thing to do now is just work on the code for the most part. I still want to add the PWM in for controlling fan speed. So I'll show you what that relay looks like real quick. If we come into the box of stuff, here it is. So this right here is a solid state relay that is automotive. And this will turn your fan on and off a billion times a second, which can control the speed. So the only thing that sucks is that this kit didn't come with a pigtail, which kind of blows. I think some of the sales on eBay did. But yeah, it's a 36143 relay. I think they're found in Jeep TJs and some kind of Chrysler minivan, I think. But yeah, if we use those to control the fans, then we can use this guy to send it the signal it needs to actually turn it on and off, and yeah, we can get variable speed. But I still have to work on that. But the other part is really just math and things like that. I want to work on calibrating the accuracy so it's like fucking dead nuts on. It's really close now. I was plotting out the accuracy curve, and it's not bad with current math, but, you know, it could still be better. So the annoying thing here is that it depends whether it's plugged into USB or if it's on 12 volts, because, you know, the voltage changes, and that changes the reference voltage, and then it's hard to figure out what's actually coming in. So, yeah, I need to figure that out. The red line is the 12 volts, so you can see that the readings are a bit higher than they should be, and on USB they're lower. But it's not by much. I mean, this is like 1%, and this is like, you know, down here 96%, 104%. It's not a big difference. Like, you can see the actual divide here. Like, when we're into 29,000 ohms, it's only off by a little over 1,000. Everything else is pretty close. So yeah, once I actually, you know, plot this better and figure out the accuracy, we should be all right. Because the if you look into other stuff, this is interesting. This is the amount of steps that we have in our reading. So reading in resistance is really annoying and complicated. But the you know, the short of it is just that it's not linear in any way. It gets exponentially. The steps, you know, grow exponentially. So down here, these are much closer together. So this is the ADC range over here, and I think this is the resistance that it's reading. So yeah, I was messing around with all kinds of different things of what it does, but things and stuff. The diode throws things off. The diode's the red reading, so you can see it kind of offsets the readings a bit. So this is kind of nothing now, but it's all about the math, partner. Math, not meth. But anyway, that's enough boring stuff. So yeah, if you're interested, I got 50 of these suckers ready to go. I just got to start putting them together. And speaking of which, the SMD assembly on this batch is going really well. Like, I don't have to touch anything really. The only problem child is really just our voltage regulator here, because it's QFN and the friggin' pads are hidden underneath. So, but usually I can put some flux on the side and just hit the sides of them, and usually the pins will go where they need to. So not a big deal, but yeah, I'm very happy with the way these are coming out. I am building them by hand. It takes about a little under 25 minutes to put all the parts on the board. And then we just run it through our sweet toaster, and everything melts into place. So yeah. So to show you off some of the options real quick, here's the difference in temperature probes. So usually the stock thing that I include is these little push-in guys. So you just push that into a radiator fin or something like that, and it'll read pretty good. There was like one or two guys that mentioned they were affected by airflow, so when they're on the highway it wouldn't read properly. But all you have to do is, you know, put like a little air shield on it, or just move it somewhere out of the direct airstream, and it works fine. I haven't had an issue with mine. A lot of others have had luck too. But if you're looking for more direct contact, we got this screw boy on the left. So this is a metric M8x1X thread. So if you can find yourself an adapter, you can screw this directly into like some kind of water port and read it that way. I need to order more that have the connector on there. I only have these long boys left. So yeah, there should be a couple. There should be more of these later in the month. So they're all in stock. But that's the two options for temperature probes. And check it out. I can show y'all off all the jacks, huh? Ain't that nifty? So we have our 90 degree over here, which I feel like is probably the most useful for people, because if this is going to be mounted on the fender, remember, you're going to be looking over the Jeep, and it's going to be hard to see things. So, you know, you can get your screwdriver in there and get the ports in, and it won't be a big deal. But for you guys that might be mounting it somewhere that's like on an angle or something like that, where it's not straight up, the 45 might be a better idea. I don't know. Seeing these adapters now, though, I kind of wish I brought the text lower so you can actually see it better. Yeah, it'd probably fit a lot better under that line. Maybe that'll be for an extra vision. And for anyone that's interested in Spade, we've got Spade. So check that out. So that's all the options for these guys. So you can, you know, order it any way you like. There is one more I forgot about. There is a rear jack option. I don't have one on me right now. But basically, we've got the side exit like this, but we also have a rear exit. So the jack would be sitting up like this instead. So the jack will come out of the back. So if you're looking for a cleaner, like front install, instead of having a cord come out the side, it comes out the back. So it might be easier to, you know, mount it places. But yeah, that's pretty much it. So, TFCs. Where can you get them? Well, time to show you off something cool. We are getting official, partner. So we come on over to the nickandtimedesign.com. Check out my sweet site. If you notice, I got a real domain now. There's no WordPress in there, son. We are official. Look at that. Good stuff. So if we come onto the page, I've tried to organize some of the tabs a little bit. So a lot of the stuff is in the support tab now. So we got our facts, we got our version history, and some other stuff. But who cares about that? We've got a shop, online store, man, on my own site. Tell me that's not cool. Oh my god. I'm super pumped about this. So, you know, there's no more, you know, going through the Facebook page and asking about pre-orders and doing this and that and trying to track everyone down and all that crap. Nah, son. It's all on the website. So I'm going to get some more official pictures so you can, you know, see everything better. I took some real stuff, but yeah, you can make pictures bigger and look at everything. And it's all in there. And it's really cool. So yeah, super pumped. Super pumped. So we've got all our options for, you know, our color, our probes, our jack, all that stuff. A little description. Look at it. Related products. In case you guys need some extras. Oh my god. Yeah, that's cool beans right there. I'm super pumped. So yeah, from now on, we'll be using the website for all of the purchasing needs. So I think that's really cool. So, yeah, I guess we'll get on to the next part. Where the heck are the REMs, eh? Well, they're still being built. So this was the first image that I got from the company that is doing the assembly. So they wanted to send a picture to make sure that they were building them correctly. And, yeah, everything looked excelente. So, yeah, that's what that looks like. This was, what, about a week ago? So I'm going to probably contact them on Monday and just check in and see how they're doing. This is not an easy design to put together, so if they're putting this together by hand, I feel bad for them, because I couldn't do it. I could not do it successfully. It takes way too long. It's too obnoxious. Tell them, dog. It takes way too long. Too much. Can't have that. This was the regular V5 board, and as you can see, it's redonkulous. The amount of little itty-bitty crap components on there, trying to get them to go on straight and successfully, and just, ugh. And then on top of worrying that your soldering job wasn't great, sometimes the bootloader doesn't even work. So yeah, that's, it's not an easy to design at all. But, in case I haven't told this on video, I figured out one of the main issues with these boards. I was putting them together, and I couldn't get any of them to work. You know, I got like the first like couple to work, and I found out I was putting this chip on backwards, so I flipped the chip around, and now all of a sudden, now it's on the right way, and nothing works. Well, after doing some digging on the forum, I found that there was a pin that was causing me issues. So see that one on the end that I have popped up? That is there for a reason. That was the input pin to a bonus, you know, circuit that wasn't really doing anything. I just had it there, and you could do something with it, but it didn't really have a use. But I ran it to one of the pins next to the bootloader, and I found out that the pin that's right next to the bootloader pins, it's a free pin, you know, you can use it, do whatever you want with it. But during the initial, like the first ever bootloader, like chip install thing, it can't be brought low. If that pin is low instead of high, the bootloader will never work. So yeah, after dicking around and messing with it and figuring all that shit out, yeah, I finally found out that was the problem. So I lifted the pin and it worked fine. So on the V5 boards, I just had that pin lifted, but I didn't make many. So on the new design, I fixed that. Along with some other things, I switched this footprint around so we can actually, for the first time ever, have a frickin' micro SD card jack that works. I've put them together wrong, or I've had the footprint wrong, or the wires were backwards, or just... oh, the diagrams, man. What a pain in the balls. you look at the pins and the pin layout's one way, and then you look at the footprint and that's from the top and the other's from the bottom, and you're just like second guessing yourself and just, oh my god, what a pain in the balls. But yeah, V5.1 will be the first goddamn freaking board that actually has a good footprint. So yay. As long as, you know, they come and actually work. That's the big thing. So, how do you get the V5.1s? How do you get yourself an REM? Well, that is going to be through the website. And this is how it's going to go down. So, once this first order comes in, this first batch comes in, and I find that they work, I plug it in and the circuits are good, I'm going to set the store to live, so you can just order them right off the website. So, the first batch should be here, I'm hoping in a week. If it's taken longer than 2 weeks for that batch to get here, I don't know. I ordered it like the beginning of October. I mean, assembly takes a while, I get it, but yeah, hopefully we can get stuff moving. But the second that batch lands, I'm going to start selling because I do have orders on the page from the initial pre-order. So first off, V5 guys that you have placed an order a long time ago, you know, we're talking months ago. There's one guy that started it all the way back in March. If you guys haven't paid, if you haven't gotten back to me, so I'm going to have to refund your deposit if you don't get back to me. I mean, I get that after a while, you know, after months and months, it's hard to keep in contacts. Things change. You don't have a Jeep anymore. You don't have money. Things, you know, whatever. It's not a big deal. If, you know, if you have to cancel or, you know, it's not a problem. It's not. If you find that you have to cancel your order, just let me know. Just respond and, you know, tell me, hey, listen, things came up. I can't order one right now. You won't hurt my feelings, I promise. You know, I'd rather know, so just be upfront and tell me, and, you know, we'll get you squared away. There are 9 people from the V5 list that haven't gotten back to me, and if I don't hear any word by December, then those down payments will be refunded, and then we'll have 9 more boards for sale ready to go. For the V5.1, people that ordered off the website, there are still 6 orders that I need people to reorder. So a little thing with the website, I thought it would be cool if you could order a product and then it wouldn't charge you until I shipped. And that's great, but there is a time period I have before the payment is canceled. So when you go on the site and place an order, I have 2 different options. You can use a credit card or you can use PayPal. Because I figure not everyone has PayPal, not everyone likes PayPal, so, you know, I'm trying to give options for people. So when you add to the cart, and we go view our cart, free shipping. Okay, so down at the bottom, you can see here, we can pay with PayPal or we can pay with Stripe. So PayPal gives me 29 days before the payment is refunded, and Stripe only gives me 7. And I didn't know about the 7 days. So, yeah, after those 7 days, I'm screwed. There's no way for me to get any payment. There's no way to reauthorize, to send another request. I'm just sitting with my friggin' hands between my legs. I can't do anything besides contact the customer and ask for them to place a new order. So I've emailed all the affected customers. Most people got back to me, but there's still 6 of you guys that haven't gotten back yet. Again, if I don't hear word back by December, then your place will be lost, and then we'll have 6 more boards up for sale. So yeah, I mean, you know, if the guys ever get back to me, then, you know, I'll put you at the beginning of the list, but, you know, I can only hold on for so long. You guys gotta respond. That's the biggest thing. If you give me contact info, you have to get back to me. Otherwise, I can't give you these pretty things. So yeah, please check your emails. Those orders were from October 6th to October 8th. 6 of you guys, so please check that. I really don't like having to refund guys and kick them out of line, but if you don't get back to me, I don't really have a choice. So you got till December. All right, you still got a month, but please get back to me. And anyway, to wrap up on that payment thing, I actually took a poll, and it's very good. Check the website. All right, check the Facebook page and all that. All like weekly updates. I tell you all about that stuff. But yeah, this was the poll. So 75% of you guys were, you know, just take the payments right away. So that's how it works now. So when you place an order, the payment is just authorized immediately. That way I actually have the payment so I can fulfill the order when I'm ready. I would like to wait, but I can't. If it's more than 7 days, it's, you know, so what's the point? I might as well just take it right away. And again, if you guys ever want to refund or cancel, that's completely okay. You know, I'm very easy to get along with. You know, if there's an issue, anything comes up, you know, you don't even need an excuse. Just let me know. I got you covered. I promise. You know, I do this for you guys. It's for fun. So it's not a big deal. It's not a super big business. It's, you know, it's just something I do as a hobby. So it's nice to see all the smiling faces when they get some cool stuff that works. So yeah, I like seeing products in action when you guys show them off and post them on the internet and stuff like that. I absolutely love it. You know, it brings a warm feeling to my heart. So most appreciated. So yeah. Anyway, so the second that this next batch lands, I'll be putting the next one live on the website, so you guys can just order. The second batch will be ordered again the second I find out the first one works. I don't want to order 100 boards and then find out that they don't work, or there's a design flaw or some weird thing. So I just want to confirm that they work, and when they're good, I'll just keep placing orders. So the page will always be live. You guys can place orders, and I will try to keep you posted on when the next shipment will arrive. With how long this is taking, the second batch probably isn't going to be here until probably mid-December. So it's going to be close. I don't know if the second batch will be delivered before Christmas, but we'll see. This stuff takes a while, man. It takes a month, or it takes like a week for the order to go through and the boards to be built, you know, the boards to be, you know, actually created. And then it takes a week for the parts to get there, and then it takes another week or two for them to be assembled. So by the time it's all said and done and then shipped to my door, it's over a month. But again, that's a month of time I don't have to do stuff. This stuff takes forever. I don't like building boards. That is very time consuming and annoying, and it's just ugh. So if I gotta wait a couple weeks for someone else to do it, that's fine. Much better. Okay, so TFCs are covered, REMs are covered. So let's talk about something a little different. Take a look at something I've been working on. Alrighty, so we're in the heap, and today I've got a little something different to show you guys. So this is a prototype model that I've been working on for a customer because he was interested in a little something different. So I present to thee the TCU Buddy version 0 prototype, work in progress. But yeah, he was interested in reading the transmission computer. TCU, TCM, transmission brain box, whatever you like to call it. So I threw together a little something or other on a breadboard so that we can read it in. So the interesting thing is, I mean, obviously if you've been following this channel, you guys have probably heard about the REM once or twice. So for you Renix guys, this thing is your Lord and Savior. It'll read your engine computer, your transmission computer, your mind, everything. And they're friggin' sweet, but there's nothing for the HO guys. I mean, sure, you got the Trinity fan controller, so you can at least control fans, but what about data? Well, that's where this comes in. The interesting thing is the HO TCUs use the same data stream, same protocol, same everything. So if you can hook up the right wires, you can read the transmission computer. So that's about all I got for HO now. The engine computers are a lot more complicated. But anyway, since this is focused more on just the transmission, there is more than just data. So it has a bunch of different lines for manual reading. So if you have any manual shifters, things like that, like solenoid shifters and shift kits and things like that, your transmission computer is not going to output the right data for the solenoids. And the TPS rating's kind of weak. It's only in 0 to 7 steps instead of like a full 100% percentage range. So I've got circuits in there so you can manually read those. So, just because I love you guys, I'll show you the big old schematic I made. So that right there is everything. It's your bread and butter. We've got our main TC over here. We've got the screen circuit. We've got buttons. We got a brake LED. We've got 5 different voltage reading circuits. One is really high impedance, which is for the TPS. That way it doesn't throw the reading off. A little capacitor, just to make the reading actually work. And then over here we've got our data line, our voltage regulator, and our jack. Pretty straightforward, nothing too complicated, but basically you can read in all 3 solenoids, the TPS, and one extra line I have no idea what to do with. Maybe the 4-wheel drive. And of course there's lots and lots of code, because there's always frickin' code. But hey, at least I'm making it kind of cleaner. We've got function tabs now, we've got our data tab, all that fun crap. And even some debugging, because things never work the first time. But anyway, enough yamming. Let's see what it actually does. So due to project simplicity, I just left this as a 2-button design. If I were to actually produce it, I'd make it 3 buttons. And obviously they wouldn't stick out so far and look so goofy. But here it is. Now obviously this is OLED. This is a 2.7 inch display. And like all weird-ass displays, they show flicker on the camera, but it looks fine to your eyeballs. So this is the main data screen. So we have our speed up at the top. We've got the gear on the top right. We've got all 3 of our solenoids, our TPS, we've got the transmission RPM, our power comfort switch, our shifter, and our brake. So if I push the TPS, you'll see that it goes up to 7. That's all you get on the transmission data line. If we push our power comfort switch down here, this guy, it's hiding, we get power. If we shift our shifter, if we push the brake light comes on. If we shift into third, we get third. Shift into first, we get first. And no, none of the other things are available in the stream, so I'm showing everything that I possibly can. But yeah, so that's the basics, and there are some options. So for mile per hour, we need a couple different things, because we're not reading from the transfer case, we're reading from the transmission. So we need to know some stuff. We need to know our tire size, we need to know our gear ratio, and we got a speed adjust. So, oh, son of a bitch. And we've got our speed adjust over here. So in case I can learn to use this, we can change the percentage. So you can get it tuned just right. On top of that, we've got the solenoid input. So we got TCU data or manual reading. And same for TPS. And that's pretty much it. So if nothing blows up, let's go for a ride, see what it looks like. So the RPM does not read until you're going about, for me it's 7 miles an hour, but it doesn't read under 300 RPM of the transmission. So if you notice, we can see the gear that we're in, we can see what the solenoids are doing, you can see how hard I'm pushing the TPS, see I'm on the brake. So basically everything that the TCU gives us, we can read. The only thing that I haven't programmed in yet is the TCU error codes, so I could put that on a different screen. You can see our torque converter locked up even though we're still in 3rd gear. That's what it does in comfort mode. And if I let off, it'll actually coast in 4th. So everything you'd ever want to know about your transmission. So there you go. That's just a little demo. Now to show the one thing off that I was talking about, so down here is a solenoid override switch. This will put the 2nd solenoid on. So when I flick it, you notice the solenoid 2 light doesn't show up. But if we were to check the error code, we would get an error for solenoid 2. That's one of the problems of the TCU data stream. It only shows what it's requesting, not what is actually going on. That's why having the manual lines is useful if you have some kind of manual setup, because you need to read the actual state of each solenoid, not just rely on the data stream. But anyway, that's just a little showcase of the TCU Buddy version prototype. I have no idea if anyone would be interested in it. I don't know if I feel like making them, especially with the OLED. They flicker, and when I'm trying to like work with them, they make this annoying buzzing sound at about 13 or 14,000 hertz. and it is obnoxious. It drives me bananas. So yeah, I don't know. They're cool, but I wish I could find a better screen. The Adafruit ones just aren't really wetting my whistle. But yeah, the original plan for this was going to be a small screen, like one that might even fit in here, so like a gauge pod version. I've always wanted to try to make a gauge pod version of something with an OLED screen. That'd be cool. But yeah, I don't know. What do you think? That'd be interesting? To put into perspective, with all the work that it took to make this, this was a $120 prototype. That's how much it cost for me to sit there and design this and code this and build this and make this. So that's how much that cost. The screen itself is $50. So that's why I don't really like working with them, because it ups the price point ridiculously. But, you know, it's a thing. I should also mention that currently this is not what I'd call a plug-and-play device. I mean, it could be for the Renix guys, because I actually, you know, I've gone through the effort of figuring out the adapters and the pins and making it all work and all that business. The HO guys, I have not gotten that far yet. I don't even know what kind of connector it is, so I don't even know where to start for the pins and what it would need, and making the 3D files and getting them to connect and all that bullshit. So for now, for the customer I'm sending this to, it is on an HO. It's a 91, I think. So I am just giving him a pigtail with a bunch of connections, so he can figure out how to wire it up. So he will have to manually wire an ignition and ground and the data lines, and if he wants to, hook up the solenoid and TPS wires. But that's all manual. You'd have to go under the dash where the TCU is and dig into the wiring harness or figure stuff out. So this isn't really plug and play yet. But again, it's, you know, it is what it is. We'll get plug and play, you know, and refinements if necessary. One step into the realm of HO, though. Halfway there. Pretty nifty, huh? So, yeah, that is a prototype. And again, like, yeah, you know, occasionally I don't mind taking in customer requests for custom projects. It's fun to, you know, try different things. It doesn't, you know, the time frame is going to be a while. You know, like I was waiting, I forget, at least 3 or 4 months, probably more, while I was just, you know, getting everything settled, because there's just so much going around out here. But, yeah. Okay, but who the heck cares about those, huh? Where's my darn clocks, huh? Where's my darn REM clocks? I want my clock. I need to know the time. I need my clock. These guys have been on the back burner for quite a while. The biggest problem is really just designing the new board. So I don't know if you guys seen the REMs, but yeah, they're a bit much. Let's see if I have the dooba-dooba-doo. Oh no, it's not in here. Fuck. Alright. So step 1 of this big mess is trying to port everything over. So I need to combine all the V5 hardware from the old board and move it onto the new board. And that's going to be a little annoying, because there's not a whole lot of space to work with, and there's a lot of wires that need to be placed. So I've been trying to make this easier by just grouping things into smaller little objects. So we've got our in-out stuff, you know, our extra pin business. We've got our new bonus jack. We've got the main chip and bootloader and all that, you know, important stuff. We've got the voltage regulator. And it should be pretty much else, everything. The USB, I gotta add the USB up in the corner. Oh yeah, and the data reading circuits, that would be important. But yeah, there's a lot to try to fit on that little tiny board, and it's gonna take a long time to try to figure out how to wire it all in. So yeah, that's part 1, is actually getting the board laid out, because there's so much frickin' stuff to include. It is a wee bit ridiculous. Apologies for this schematic. Again, I'm trying to recombine everything, and yeah, porting over schematics is rather obnoxious. Fritzing probably isn't the best thing to use for this stuff, but it's what I know how to use. So yeah, part 1 is laying out the board. So once we have the new board laid out, that's not the full story. So once I get it, first, you know, second, I got to make sure it actually works. But once it works, I'm actually going to be sending the board out and this design to someone that's been contacting me on Facebook for a while to see if I can get injection molded cases. Because if you look at this, this ain't exactly the prettiest. 3D printing is not, you know, picture perfect. There are ridges and lines, and it just, you know, it doesn't look incredible for some people, I know you don't care, but the biggest problem is it's hard to print these. All these indents that actually make them look factory, that match the factory indents, that's really difficult to do. And all it takes is one of these stupid little lines to get messed up and the whole panel's ruined. I cannot count how many freaking panels I have laying over here because one stupid little thing happened and completely ruins a 3.5 hour print. It is so... I hate printing those things. So that was the biggest reason for moving away from 3D printing. Is it takes too long and the success rate is just too low. It's aggravating. You know, when you waste all that plastic, all that time just to find out the damn panel doesn't work. So I'm going to send these off and get them professionally injection molded, so that way I don't have to worry about printing. I just snap them all together, good to go. They will look pretty and beautiful. The reason why these have taken so long is because I had so many problems with it. I cannot count on 2 hands how many problems I've had with these clocks over hardware design, over software design, debugging them, printing them, making them. It is the most difficult project I have ever taken on. It is ridiculous. So yeah, they've been put on the back burner to make sure that I get them perfect. Because I hate when, you know, I send out a bunch of product and everyone's having problems with them. You know, it's not fun to constantly give excuses and explain why things don't work. I don't like doing that. I like to make things that actually work. So yeah, I've been waiting until the moment is right. So now that the TFCs are good and the REM should be good, now I can probably focus on the clocks, get the clocks going, send them out so that we can get cases. Then when we get cases, everything should be smooth. So 2019, man, things are looking up. Things are looking good for 2019. So yeah, we got the website, we got pretty products, and then it's just down to software. I need to do a little REM software stuff, you know, just add in features like the new the multimeter jack, the new clock system. I want to do data logging. I want to do a no start analyzer, so to look at all the data, figure out why your engine doesn't start. I want to make a list of every single possible readout in just one easy to read list, so you can just go through all the readings real easy. Better check engine light that's, you know, actually kind of smart. Things like that. There's lots of, you know, smart code I want to add, and I can't really switch back and forth. Well, I'm either doing the hardware and doing little software, or I'm in this guy and I'm doing deep software, digging into the ECU and, you know, all that stuff. So yeah, once boards are laid out, I can switch to software, and then after all of that, when the REMs are good and everything, I'm happy with it, things are in stock, things are flowing, then maybe I'll get into the HOs. So I already hit the transmission computer. You saw that. So the computer was good. Next up is going to be this friggin'... Next is going to be this monster right here, the HO data harness. So yeah, I've got a little plug and I've got an ECU laying back there. So eventually I can try to dig into that. So yeah, OBD1... Again, eventually, I'm not even going to give a time frame because I have no idea. I thought I was going to start that years ago. So, you know. Okay, enough blabbing. Thanks for watching. That is the current progress of the Nick and Tom design team. So, later, y'all.